Hey everyone, it is time for another recitation, this time on our useReducer to-do app. So this is not the first time we have written a to-do app, nor will it be the last. This is a pretty good default project when working within different front-end frameworks and different styles of writing different front-end frameworks for having an application that has all of the basic things that we need when building a larger application, which is kind of state management, nested state management, users typing into a form, submitting things, clicking on other stuff. It's kind of a great base level for the types of things you'll be needing to handle in any web application. The big difference compared to our previous one is now we're going to manage state using the useReducer hook, which is a departure from our previous state management tool, which is the useState hook, which lets us manage state in individual variables. With useReducer, we kind of package our state all up into one big object, and then share that where it needs to be shared, and then control all updates to that state object within our reducer function. And this pattern is helpful as our applications get larger and more complicated and our state becomes, very interconnected. Being able to handle that all in one place is very convenient. Here, we really only have one thing in our state, which is our to-dos, so it's not necessarily a shining example of when we would want to use a reducer, but it's a great place to start. So, for MVP today, we're going to build a simple reducer for our application. We're going to hook our application up to it, and then we want to display a list of to-dos, have a form where a user can add a to-do, and then can click on the to-dos to toggle them as completed or not. And time willing, we might touch on some of these stretch items. So I have here my React app initialized and started, and there's nothing in it. We just have a bare application. But before I start touching on any of the presentational parts of my app, I want to start up the structure for my reducer. So I'm going to create a file called reducer. A folder directory called reducer. And then in the pattern of lecture today, I'm going to create a file in here called index.js. That way I can just import the folder and it'll grab this file for me. I need to declare and export two things from this file. I need to declare and export my initial state. And this is going to be an object. And this is where we run into the first problem that we were seeing yesterday. And one second, I had forgotten to mute people joining by default. As always, feel free to unmute yourself if you have questions. So if we look in the README, it's very easy while quickly scanning this document to see initial state and then see this code snippet and go, well, that's my initial state. But this is wrong. This represents the state of a single to-do object. That's not what we want. In order to make this application work, we need to be able to add and edit multiple to-do objects. So these need to be inside of an array. So next, as people kind of encountered this, they'd say, oh, okay, so this needs to be wrapped in an array. Good, I'm done. That's not quite it either. When we're dealing with state inside of our reducer, we always want it to be an object. And you won't actually get any errors necessarily if you make it an array, because an array is a type of object, but it kind of defeats the purpose of using a reducer and this state object. Because the point is to organize our state in such a way that all of our application's shared state is in one place, and our reducer function is able to modify all of that state as it needs to inside of each action. So in this case, even though we only have really one thing inside of our state, which is this array, we still want to put it inside of an object, and then put this array under a key that I'm going to call to-do, let's just call it to-do array. I've fallen into the habit of calling this something like to-dos, which is fine, but visually the difference between to-dos and to-do and to-do and to-dos, which are those words capitalized or not, can be difficult to parse. So there's nothing wrong with naming your variables and your keys and your functions explicitly so that you know what they are. There are no bonus points for making them incredibly short. Obviously, don't make them unnecessarily wrong, but naming things well is a skill that requires practice. I could also call this to-do list. I'm going to keep it as array. And so now we have this array within our state, and even though we don't need anything else, the benefits of putting this array inside of this object is that if I needed other things, like to-do count, I can just add this as another key to this. Or maybe I want to keep track of the IDs as part of my state, so that as I make each new one, I can grab an ID out of the state and then increment that, so our state is able to grow. That's why we want this in the object, even though that's just the only thing we're going to have inside of our state. Okay, so now we need to write and export our reducer function. So our reducer function takes two arguments. It takes the state and an action. And notice that this is the function signature of a reduction function. When we call the reduce method for an array, if I were to do, some array.reduce, what I would write is a callback function that takes something we often call the accumulator, and then an element from the array, and returns some updated value of the accumulator. And this is why we call this a reducer, because we're going to perform whatever action we need to on the state, and then return an updated value of state. And that's what's used as the next iteration of state and the re-render of our application. So it is a reducer function, and we're reducing over this queue of actions that we've dispatched. We kind of add these actions as messages onto this queue, and then our reducer function reduces over that and then produces our nice updated state object that comes back into our components. So for our reducer function, by default, we're going to write a switch statement in here, and this is going to take a value to switch off of. This basically acts as an if-else tree if the only thing we're doing is trying to compare the value of a single variable to different possible cases that it could be. So we could also write this as if action.type is equal to something, and then otherwise else if it is equal to another thing. But the switch statement lets us do that a bit more easily. At the bottom of our switch, we always want to have a default handler if it doesn't match any of the cases, and there we're just going to return the state we were given back in. And for some reason my formatter likes to format the switches weirdly, so that's just how it's going to look. Alright, so this is our basic initial state and our reducer. Do we have any questions at this point?
I had a question, Henry, regarding why does the initial state have to be an object, and if you set it to an array, why couldn't you work with it as an array?
Okay, so I mentioned some of that a little bit earlier, which is you won't get errors with the array, but it defeats the point of using the reducer. Because the idea of the reducer is that we can track our state, the shared state of our application inside of a single structure, and then update that as we need to as the user interacts with our website. So an array would work, but what happens when you also want to keep track of another piece of information besides that array? Suddenly you're stuck, because there's no way to add information laterally to the array. If we wanted to keep track of the user input, for example, inside of our state, that's something that we can absolutely do. So that we wouldn't need to pass as a payload the value the user had typed into a form when they added to do. It's just already in our state object. But if our state is an array, then we can't do that. So the point of the state being an object is that it can contain all of the shared state that our application requires to function. And in an object, adding to this is as easy as adding another key. There we go. If this were an array, I would literally be unable to do that. Part of this confusion may come from the fact that, we only have this single value, so the object seems overkill. Another thing that might help this is the fact that we refer to this as state and it's an object should recall the way we handle state in class-based components. State there is an object. And if we want to have more state, then we add it into that object under a key. And everything lives in that object together. And that's not always a great paradigm for our state, because sometimes we have these logically distinct entries that are getting coupled together within our state object. And that's why in our hook, we're allowed to create these individual stateful variables. But here we explicitly want the pattern that is enforced in class-based components. That the shared state, this logically interconnected state that represents, the working version of our whole application, wants to live together so that we can update it in a single place inside of our reducer function. And if we have an array, we simply cannot do that because the array in its formatting can only represent, a single sequence. It cannot represent multiple disparate types of data the way we can with keys inside of an object.
But I understand. But theoretically, if we only had one key on the object, we might as well just use an array, like in this example, if we didn't need to add anything else to a state object.
Theoretically, yes, but I'm going to come out hard and say you should never, ever do that. The whole point of the reducer pattern is that state is an object that contains the shared state of our application. Even if that is only one key in this object, the point of this, pattern of, this message passing and reducing style of state management is that it helps our applications as they grow. So even if we start with a single piece of data, this to-do array, using that as state is counterproductive to the goal of this style of state management, because as our state grows, we need to be able to add to it. And this is what this pattern helps alleviate, is as our applications scale, how do we handle updating our kind of massive state tree and then sharing that to the components that need it. So using an object, using an array would theoretically work, but it is exactly counterproductive to the thing we're trying to solve here. And this might also be helped by the next thing that I'm going to do, which is I'm going to remove this to-do input because we're not going to do that for now. But how we use this reducer inside of our component. So we do this by importing the useReducer hook. If I can spell this right. useReducer hook from React. And then we call this inside of our application. And we're going to destructure the state and the dispatch function from our call to useReducer, in which we give it the initial state and our reducer function, which I'm also going to need to import. So I'm going to import the initial state and the reducer from just /reducer. And I'm going to pass that to my useReducer, which is going to be in the form of the reducer first and the initial state second. So,
excuse me?
Yes.
So can you please explain what exactly is happening here? Why is the reducer first and the initial state is second?
Yeah.
Thanks.
I did want to touch on that. I did see some confusion about this. And ultimately, it's because that's the way it is. That's just the order they decided to declare the arguments on useReducer. If they had declared it the other way, then we would do it the other way. You will see this kind of pattern of the reason these arguments are in this order is that, so our reducer is a function, and it takes initial state as an argument. So as we kind of read this left to right, the reducer is going to take in the initial state. And it kind of mirrors the application of the reducer on the initial state. Because inside of this useReducer, we are going to apply the reducer function onto the initial state, and then any actions that are dispatched. So that would be my assumption as to why they chose that order, but ultimately that is just the interface that was given to us. And you can always check the documentation as to why that is the case, because we'll contain the argument list for that function. But I want to focus on here what we're doing and how this relates to what we've already done, which is let's take a look at how we would handle our state if we were doing a use state. So we would destructure our value and then our set value function. I'm just going to call it state and set state. And then we make our call to use state, and then we give it the initial value that we want for state. Notice how these are virtually identical. The idea of the useReducer hook is that it's an addition upon the use state pattern. So as we destructure on the left side, we have our value, and then a function that allows us to change our value. This is exactly what we're getting from useReducer. We're getting our value, and then a function that when we call it allows us to change the value of state. Dispatch does this in a somewhat convoluted manner because we dispatch an action which is then handled by our reducer function, but it ultimately serves the same purpose of set state. We are just abstracting the logic of setting that state from wherever we use set state to inside of our reducer function. Same way, when we call use state, we have to give it an initial value we want our stateful variable to have. When we call useReducer, we're giving it the initial value we want our state to have, and we also have to give it the function that we want to manage the mutations in our state when we call dispatch. So this is a replacement and an extension built upon use state. In fact, if you really wanted to, you could implement useReducer as a custom hook on top of use state. And I would hazard to guess that that is how it is built behind the scenes. This is not a replacement for how we pass state around our application. And I'll talk about this in a bit once we get it set up. But I saw a lot of people treating the useReducer hook like they would treat the useContext hook. useReducer is an extension upon use state. It is not inherently tied to useContext, which is a different way of handling passing data instead of via props. We still use props or context when we use useReducer. It just replaces the pattern that we would have for use state. So that is what we are doing here. And some of you might again question why we're doing this if it's so convoluted. Well, last week when we were testing, a lot of you had questions of like, how do I test the functions that I wrote inside my application that manage, my state as it updates? How do I test those? And the answer is, well, you can't, because they're tied inside of our application. In React testing library, we're just kind of testing how the application works as it is shipped off to our user. Now, the function that handles the way our state is modified and managed is outside of our components. So we could write tests to our heart's content, checking to see that this reducer function does what we expect it to when given the appropriate arguments. So one of the other big gets of this pattern is that it makes our components dumber, which is the drum that I continually beat. The more logic we have inside our components that is not presentational, that it does not reflect the flow of data in via props or some other method that then turns into JSX that the user sees, the more state managing logic and fiddly bits inside of our components, it makes them smarter, and that makes them less reusable, and that makes it harder for us to change the way our application works on fundamental levels, because we have to jump between component to component. We'll see if you had structured your components that we're going to make to make our to-do app work in the dumb fashion so that it accepted everything they needed via props, all you would have to do was swap out how state is managed inside of app and then pass the appropriate props to those components, and you would be done. So if we
But
keep... I'm sorry, what was that?
yeah, sorry to interrupt. But yeah, regarding that point, but the logic has to be in some component. So one component is going to be smart, like
Yeah,
maybe app,
yes.
right?
But using this reducer pattern, we are making app dumber because most of the logic is now going to live inside of our reducer function. An app is largely unaware, it is completely unaware of the contents of this function. So app is now becoming dumber. This is one of the big advantages compared to useState, is we would have to write the logic necessary to update all of our different state variables inside of our app, which makes app smarter. Using this reducer, app is now dumber. The reducer function now contains that logic, which makes this easily testable and easier for us to change how this works without app knowing the difference. So that is what we're doing here. And as well, with the actual Redux project we're seeing today, it helps make app even dumber because app is as well completely unaware of the dispatch function. We don't have to write any wrappers for that. We just hook up our dispatch functions directly to the components that need them. But the whole point is making our components dumber is generally a good thing. So I have my app hooked up to my reducer and my initial state, and we're still not really doing anything with this. I'm going to add a console log in here that console logs our state so we can see it. And there we go. There is our state object that contains our to-do array that contains our to-do object. So I want to render this to my screen. First step, when I'm doing my projects, I want to get stuff on my screen as soon as possible because that helps me know if I'm doing things right or wrong. So I'm going to create a components directory, and then inside of there, I am going to create a to-do list component. I'm going to import React from React. I'm going to declare my to-do list function, which is going to take in props. I'm going to export to-do list, and then I am going to return, for now, just an empty div that has to-do list inside of it. I'm going to import this into my app.js, so I'm going to import to-do list from /components to-do list, and then I'm going to render this here. All right. Export default to-do list. There we go. All right, so we got something on our screen. So the idea behind to-do list is we should give it some to-dos via props, and then it wants to render those into a list. And we have our array of to-dos inside of our state. So I'll give it a prop called to-do array, and then I will give it state.to-do array. And now in here, I can access that prop. I really like destructuring my props. I think that kind of reinforces the pattern to me of, you know, these props being essentially arguments. So that's what I'm going to do. So I'm going to destructure the to-do array from my props. And then now I can map over to-do array. And then for each of these, I'm going to get the to-do object. And then I'm going to render. I'm just going to do a component in line here, and this is going to have the todo.item, which we can see in our state is the name of the text that shows up for our to-do. I'm going to give it a key, which is going to be the todo.id, so that we have a unique value there. All right, and now we have our list of to-dos showing up on the screen. Notice that to-do list is a very dumb component. It receives everything it needs via props. Does it care that to-do array is coming out of a state object that we made with a reducer, or that it's coming out of a useState hook, or that it's coming out of state within a class-based component? No, it does not. It just knows that this is going to be an array full of to-do objects that it's going to take and do its thing with. So if you had written your to-do list or equivalent component when we did the to-do project last week in this manner, you could reuse it entirely. If it accepted everything it needed via props, you would just have to change the way in which you passed props from it, and then it would work. So this is the advantage of our dumb components, is they don't care about how our state is managed. They just need the data that they need. So now we have our to-do list going. I want to now create my to-do form component. Let me create a file called todoform.js, and I am just going to create a normal form. I'm not going to use Formic. Formic is a wonderful library, but it is a bit of overkill when we have a single input. So I'm not going to add the additional overhead of another dependency, as well as managing all the complicated things we need to do to get Formic working. So this is going to return a form, and that's going to contain an input. Type is going to be text. Name is going to be item. The placeholder is going to be to do. Then I'm going to add a button of type submit. And this is going to say add to do. And I need to set up my state. Even though we're changing our state management to this reducer style, components can still have local state. It is entirely acceptable for this form component to manage state on its own, not inside of my shared state that I'm handling with the reducer. Could I put this in the reducer and manage it that way? Yes, I could. But the contents of the state of this form is kind of an implementation detail of how this form works. And I'm going to pass the data I need out of it via, calling a function while giving that as an argument. So it's not really a big deal. We can still have local state in our application inside of each component when necessary, and that is fine within the useReducer or the Redux pattern. The state object is there for shared state, state that other things want. And that is the advantage of the pattern, is that it makes it easy to share that state everywhere. We don't really need to share this. So I'm going to use my old tricks. So I'm just going to call useState and create a stateful variable for my item, and then set this up as a managed input. So this is going to take a value, and that's going to be item. This should not be a period, that should be a comma. And let me format this just a little bit nicer. Okay, and now I need to write my handle change function, which is going to take in an event, and I am just going to call setItem and give it event.target.value. I don't need to do the whole object thing because I have a single input. I can just use a normal variable that contains the string itself, and then I will add my onChange function to be handle change. All right. Now I can import this into app.js, to-do form, from components, to-do form, and then I can render my to-do form. And there we go. It shows up. I can type in it. I can click this, which currently just files a normal submit event, but I'm going to implement the rest of the behavior that to-do form needs right now, and we're going to hook it up to our reducer second, because the point is this to-do form is allowed to be completely unaware of how our state management works. The idea is that we want to have a function here that handles the submit event. And this is going to take in an event, and I need to spell const correctly, and it's going to call event.preventDefault just like normal. And what it's going to do is we're going to expect some function that comes in via props that I'm destructuring here called add to do. And what we're going to do is we're going to call add to do, and we're going to give it the value of our input as an argument. And then I'm also going to clear the value of my input just for good housekeeping. And we're done with to-do form. To-do form does not have to know how add to-do works. It just needs it as a prop. Our form remains dumb. We can swap rapidly between using reducers and using state and using class-based components and using Redux, and to-do form won't know the difference because it just needs this argument, this prop add to-do, that when it calls it and gives it the text for the next to-do, it does whatever it needs to do in order to add that to our application. To-do form remains ignorant of how this works. The way we would get it to work is to write a function within app called add to do. And normally we would have to write some logic in here to handle adding the to do to our stateful array that contains all of these things. But instead, what this is going to do is it's going to take an item as an argument, and this is going to call dispatch, which is going to dispatch an event. I'm going to call the type add to do, and then I'm going to give it a payload that is the item, that is the text of the to-do we want to add, and then I can pass this to to-do form as a prop. And now to-do form has everything it needs to work. If I type it here and click add to do, did I not save this file? Oh, I forgot to, I always do this. I write my handle submit function, and then I never add it as the submit handler on the actual form element. So now to-do form has everything it needs to work. I can type in here, click this, it calls that function, great. It didn't actually do anything because we haven't implemented that functionality in our reducer, but to-do form doesn't care about that. It does not care, right? I could switch out, yes.
Sorry, could you just quickly cover why you did add to do in the app.js and not within to do form? Are you trying to make to do form as dumb as possible?
Yes.
Because I added that whole dispatch bit in the to do form.
Yes, yes. I could absolutely, instead of passing add to do as a prop, pass dispatch as a prop. And then now I could write this logic inside of here.
Right.
The problem with this is now my to-do form is inherently connected to the way my application has chose to manage state. It is now smarter because it has to manage what this dispatch means and the type we're dispatching and all of these things. And let's say I wanted to rewrite this application using Redux, which works very similarly. Our reducer function could actually remain unchanged, but we would have to change, you know, how we handle the props being passed to this and how we write our action creator functions. Suddenly this to-do form needs to be rewritten because it's inherently tied to this pattern. But if I abstract away how the add to-do function works, then I could easily drop this into a project that uses any other kind of state management, and as long as I give it an add to-do function as a prop, it will work, entirely unaware of how that function is implemented. The other issue with passing dispatch around is this is kind of the keys to the kingdom. When we call dispatch, we can dispatch an action with a type to modify literally any part of our application's shared state, which as our applications grow is going to get pretty big. And so, again, I have to be concerned as a developer on a project where I didn't write every component, where I see that to-do form is taking in dispatch, and now I have to be concerned that to-do form could modify any part of state that it wants to at any point in time. But if I don't do that, and it just has this add to-do function, suddenly, without investigating to-do form, I know the only ramifications it can have on the state of my application. And that's good as a developer, to be able to read this line of code and understand what to-do form does, as opposed to having to read all of these lines of code. That makes us more productive. So there's a lot of benefits to making our components dumb. So I'm going to remove dispatch from to-do form and keep it with add to do. And this could be a class component as well. You could reuse your class-based component from last week if it had been set up in this dumb manner, because you would be giving it, you know, this function as a prop. And now you just change how that function is implemented when you pass it as a prop. So now we actually need to get add to do to work, because we're dispatching this event, but we're not handling it in any way, shape, or form. To do that, we need to pop over to our reducer file, and we need to handle a case within our switch, because we want to handle each different type of action that we produce inside of this function. So I'm going to add a case for when our action has a type of add to do. And then I want to return an updated value for my state, which as a default, we always want to return a new object and then spread the existing state into there, because this is going to give us a copy of state, and we can add below this any keys that we want to update along the way. So this is our default way of handling things inside of our reducer function. In this case, the key we want to update is toDoArray. And I want to talk briefly about what action is. I'm going to comment this out, and I'm going to add right here console.log action, which is something that I recommend all of you do when you're working with these kinds of reducers while you're learning how to do this. Because now, when I see that I type in here and click add to do, we see that we get this console log for our action. And notice how it has this type in this payload. If we look in our dispatch, our action is literally this object. If I wanted to, I could add another key called hello. Salutations. And now, when I type in here and click add to do, that shows up as my action. The action is just this object. There's not anything spooky fancy going on behind the scenes here. And we call payload out of tradition and type out of tradition, but these are just keys inside of an object. We can call them whatever we want. In fact, I don't really use payload that often. I try to name the data that I'm passing as something more relevant to what it is. But I'm going to stick to payload here for the sake of consistency. So, Jason asked a question in the Slack. Does the return inside of the case statement eliminate the need for break? Yes. So when we do cases, if I were to just write some code in here, like console log, it's an add to do, our code would continue running from top down, and it would keep trying to hit additional cases to see if they matched. Normally, we would put a break keyword in here, which would stop the switch from executing where the break runs, but the return implicitly shortcuts our function and makes it stop running and immediately return this value. So we don't need to use break. If I added a break here, I'm not getting this error, but it might actually tell me that this line of code is unreachable because the return is going to stop this from ever executing. So, yes. All right, so now what we want to do is we don't need a... why is it? Oh, it's because I haven't added the to-do array. So what I want to do is I want to add a new to-do to the end of my array. There's largely two ways of doing this. The first is using our ES6 spread operator to create a copy of state.toDoArray and then add a new element onto the end of it. In this case, it's going to be an object that contains all of our properties that are in our objects, which, let me get those on screen. So that's going to be an item, which thankfully we passed with the action object under the payload keyword. And that's going to contain the text for the to-do that we want to add. So I access this with action.payload. Action's just that object. I need to add completed to it. In this case, since it's a new to-do, it needs to be false because we wouldn't add it to our list if it wasn't, if it was done already. And then I need to give it a new ID, and I'm going to use date.now, which is going to give us the number of milliseconds since January 1, 1970, which as long as we don't submit to to-dos in the same millisecond is guaranteed to be unique. I see a lot of people using math.random here. Don't do that. That is not guaranteed to be unique. Will you likely have a collision? No, but it's not a good idea to use math.random to produce IDs that you want to be unique. If you want to use randomly generated unique IDs, look into the UUID, which is specifically designed to be a random string of letters and numbers that the likelihood of you getting a collision here is so astronomically small that it is not going to happen. The JavaScript math.random function has no such guarantees. And in fact, in an actual random function, you should get repeats. Like, that's how randomness works. If you flip a coin, you're going to get heads twice in a row. That doesn't make it not random. Whereas the UUID is designed to not get repeats, even though it is randomly generated. So don't use math.random for IDs. Okay, so now we have our add to do action handled. So I should be able to type in here, click add to do, and even though I have changed the functionality of how this add to do function works, to do form is unaware, and it works. There we go. Right? To do form is dumb. Our reducer is smart. App.js is moderately less smart than it was if we were managing how this was handled inside of App.js. So that's a win for us in terms of the reusability and testability of our stuff. Because if I wanted to, I could write a test for this reducer function, because it's just a function, and that's good. That's good. So, do we have any questions here?
Can I ask a question about like in the reducer file?
Yeah.
What are the drawbacks of just doing so like for my first case, doing like a const new to do equals, and then in the object put like item colon action dot payload ID.
Yeah, there's nothing. In fact, that helps our readability a little bit. Using you know, names for objects and elements that we're creating on the fly, and naming our callback functions and things like this is a form of documentation. And so this is now a little bit more legible to someone reading this code for the first time, because this now has a name. Oh, it's a new to-do object. That's why they're doing all this stuff, to add it to this array. That makes sense. I just did it in line like this because it was less code to write. But doing it this way and naming our stuff is definitely a great way to handle this. Names help. Good names help.
Thank you.
The other way to do this, by the way, not using our spread operator, just to show you, is there's a array method called concat that is like push. It will add the new to-do to the end of this array, but it won't modify the array that it was called on. It will just return a new array with the new element at the end. So both of these are pretty much equivalent. Just wanted to show you both. So any other questions with this before we get the completed toggling working?
Yeah, so for the IDs and all that, you actually initialized it in your initial stage, right? That's how you set it up.
So for the hard-coded learn about reducers one in my to-do array, yes, I had to give it some default ID that it needed. But for each subsequent to-do added, I programmatically determined the ID with date.now, because for the purposes of this application, that's guaranteed to give unique IDs whenever I add a new to-do. If I wanted users to use this application, I wouldn't have a default to-do in there because that's not useful for them. But I have one in here for the purposes of having one show up whenever my application refreshes. Does that answer your question?
Yes, it does. Thanks.
Okay, great. All right, so let's get toggling working. We're gonna do this in the same way. We're gonna make this dumb. So to-do list, right, takes the to-do array and as an argument what if it takes another argument called toggle to do? And I'm going to add this. I'm going to format this a little bit better. And this should probably be a subcomponent, but just to keep the number of files in this project down, I'm not going to write it that way. So what if it calls on click? It's going to call the toggle to do function, and we're going to give it the to-do's ID, so it knows which to-do needs to be toggled. In fact, this is how you would have implemented this in your class-based component, most likely, unless you pass the set state or equivalent function down and put this logic in here, but that would have to make this really, really smart. And this makes this really, really dumb. We're calling toggle to do, we're giving it the information it needs to identify the to-do that needs to be toggled, and we're letting however the inner working of this function is implemented take over from here. So this is all I need from my to-do list. Now, inside of my app.js, I'm going to write a function called toggle to do, which is going to take in an ID, and it is going to call dispatch, and it's going to dispatch an event of type toggle to do, and it's going to have a payload of that ID that was given as an argument. So now when I click on these, we should see in our console log, I forgot to add this as a prop. So now we have to pass the toggle to do function as a prop to the to-do list. And now when we click on this, we see that we have indeed dispatched an action of type toggle to do, with the payload being the ID of that to do. So I can now handle that inside of my reducer. I'm going to add a new case, this time for toggle to do. And again, you may notice that all the logic I'm writing here is going to be essentially the same logic that you wrote when you did this with class-based components. Really what we're doing here is changing our organization a bit, how we manage the, modifying this state in this non-mutating way with, the spread operator or the concat or whatever should have been the same way you were doing it inside of your class-based component. So for the case toggle to do, I want to, again, return an updated copy of state. So I'm going to return a new object, and I'm going to spread state in there. I want to change the to-do array key. And what I want to do is produce here an array that is identical to the to-do array that is currently in state. But for the to-do that I clicked on, I want to flip its value of completed on or off. There are a lot of ways to do this. I think the most straightforward one, albeit not the most efficient one, is to use map, because we can map over state.toDoArray, and we can get in a to-do object, and then for each of these, I can check, I don't want a semicolon here, I can check if the ID of my to-do is equal to my action.payload, which remember is the ID of the to-do that we clicked on, right? We're giving it the to-do ID. And this is why it can help to not name this payload. So if this is the one we want, then we're going to want to flip its value for completed. If it's not, then I just want to return an unmodified version of the object that I was given. So in the case that we do want to flip the value of completed, we now have this problem, where I want to return an object that is identical to the one that I was given, except I want to modify the value of one of its properties. How do I do that? It's literally what I've been doing here, where I spread state and then choose to modify the value of the to-do array key. So I'm going to return a new object where I spread in the current value of to-do, but I'm going to modify completed. And what I want it to be is the opposite of the current value of completed. I can do that with the not operator and give it to-do.completed. So that is going to flip the value of the current one for completed, and then put that inside of this new object that I'm returning. So now, when I click on this, it should toggle its completed status. And if we look at the state that we're logging, we'll see that right now it's false. And when I click on this, and then inspect this state, it is now true. Nothing's happening on my screen because I don't have anything set up to display the difference between those, but easy enough to do. So let me do that, and then we can pause and ask for questions. The most common way to handle this is to programmatically set the class name of this div. And what we can do is we can see, okay, so if the to-do is completed, if that's true, then I want to give it a class name called completed. And there's lots of other ways to do this with ternaries and you know, things like that. But that's the way I wanted to do it. Why did it not like this? Oh, it doesn't like this because it expects a string. So in fact, I should use a ternary here. And in the case that it is not completed, I'm just going to set the class to be an empty string. So there we go. Now I can modify my my app.css, and whenever something has a class of completed, I'm going to set its text decoration to line through. So now what should happen, let me refresh my app to pick up those changes. I should, when I click on this, get a line right through there. Alright, so does anyone have questions about how we did any of that? Alright, we feeling good about that one? Okay. Well then, let's do clear completed. That's the last thing we need for our MVP. Again, I'm going to implement what's necessary in to-do form first because I want to make this dumb. I'm going to add a button. It's going to say clear completed. And this adds the button to my screen, which, let me hide my face in the recording so you can see. So now we have this button. And one weird small note is that if we click on this, even though it is not of type submit, it still fires a submit event. So to prevent that from happening, to prevent the default behavior of this event, I need to write another handler. I'm going to call it handle clear. It's going to take in an event, and it's going to call event.prevent default to stop that from happening. And now I'm going to add this as an on-click property to clear completed. Great. So now when I click on this button, nothing happens. It doesn't do anything yet. But we want it so that when we click on that button, we want it to clear all of the completed items from our to-dos. And should to-do form know how that works? Nah. It's not its deal. It should probably just accept via props a function called something like clear completed. And then when we click on this button, we can call clear completed. Does to-do form have to know how that works? Nope. In app.js, I'm going to write another function called clear completed. It's going to take no arguments, and it's going to dispatch an event with a type clear completed and no payload. We don't need to send along any additional information. All the information this event needs is already in state, so don't have to give it a payload. Payloads are strictly optional. Strictly optional. So now I can pass this as a prop to to-do form, so clear completed. And I'm going to give it the clear completed function. And we'll see that when I click on this, we fire the event for clear completed. Problem is we're not handling that yet. So I'm going to switch over to my reducer file, and I need to add another case, this time for clear completed. And what I want to do is return an updated value of my state variable. So I'm going to return a new object. I'm going to spread state in there. And then I want to modify one of the keys. I could also modify more than one, but I just want to modify ToDoArray. And I want to produce an array that contains all of the items that are not completed, and removes all of the ones that are completed. So a great way to do that is with our filter function. Yay, these array methods, we taught you them for a reason. They're super useful. So I want to filter state.toDoArray, and filter takes a callback, and it returns true if we want to keep the element in the resultant array, and it returns false if we want to discard it. So I'm going to do this the wrong way first, which is the way that most beginner programmers write this, and I just want to show you how we can write this more correctly, because it helps you appear as a more experienced programmer, because straight up everyone does this when they learn how to program, which is we want to return true or false depending on something. So our brain goes, aha, great use case for an if statement. We can check, and we can see, okay, so if todo.completed is true, then I want to return false. Otherwise, I want to return true. Because if it's completed, I want to remove it. If it's not completed, then I want to keep it. And let's check and see if this works. Let's add a couple to-dos in here. Okay, and I'm going to complete 2 of them. And I'm going to click clear completed, and it removed them, and it kept the other ones. So our logic is good. But whenever you're using an if statement to return true or false, this should kind of be a light bulb moment, where you're like, how does an if statement work? Well, we write an expression in here that evaluates to either true or false, and that controls which branch we go down. So there's usually no need to return true or false here. We can usually return the expression that we have. In this case, we're checking to see if ToDoCompleted is equal true, and if it's true, we return false, and if it's false, we return true. So what we're doing is returning the opposite value of ToDoCompleted, which is the same as doing this. The not operator gives us the opposite value of ToDoCompleted, and we can just return that right away. We also don't really need to use an explicit return here. We can really shorten this one up so that it looks nice and clean. And this has the exact same functionality, and we can test this out. I'm gonna mark all these as completed, clear completed, they go away. So there we go. That is MVP. So what questions do we have at this point?
Hey, Henry, can you remind us how you got props down to your to-do form?
Yep. I gave it props where I rendered it here. And then inside the to-do form component, I accepted the props as an argument. I did this inline destructuring here because that's what I like to do. This is literally equivalent to me taking props as an argument and then doing the destructuring here. But it's the same old way we pass props. Right, the useReducer doesn't do anything special with how our state is managed around our application. It does a special thing with how we update state. That's what the reducer function does. But if I want to get this state variable to each of my components, I still just excuse me, um, I still just pass it, via props to anything. I could also use the context API. Context and reducers kind of go hand in hand, and you'll see today in the Redux project that Redux was written before context or the useReducer hook was added, and you can actually implement most of Redux with context in the useReducer hook. But we're still just using normal props. Something that I saw a lot of people doing was they would say, oh, I need access to, in my to-do list component, I need access to state so that I can get the to-do array. So why don't I call useReducer here? The problem is this is going to create a brand new version of state that is entirely disconnected from the version of state that is in app.js. Because this is like calling useState. It's not going to give us the same state variable we declared in a different component. It's just going to give us a variable that happens to have the same name. And so these wouldn't be connected at all. We have to use props or context or any way we choose to pass data around our application. useReducer doesn't give us any special way to manage that. It's just an extension of useState. Does that answer your question?
Yeah, and can you show us the same thing? I should have asked you not for to-do form, but to-do list. I think part of my confusion is how I'm getting the to-do array.
Yes.
Down into the list.
Yeah, so here in the bottom I have app.js. So I'm giving it a prop called toDoArray, and I'm giving it the value of state.toDoArray, because inside of my state variable I have a key called toDoArray, and that contains the array of all of my to-do objects. And so I pass that as a prop, just like normal. And inside of to-do list, I accept it as a prop. And again, I did the fancy array destructuring thing in line here, but this still just takes props as an argument. And what I did is pretty much equivalent to destructuring it on the first line. Props still work exactly the same. Right? Reducer has done nothing to the way that props work. I'm still just passing the data around. Does that make sense, or are you still having some confusion here?
No, that was super helpful.
Oh, okay.
And then, but now that I'm looking at this, why don't you need props.todo.id and props.todo.completed?
Yeah, that's because I'm using the destructuring here. I'm grabbing toDoArray and toggle todo out of this props object. If I didn't do this, then you're right. Then I would have to do props.toDoArray and props.toggleToDo. But I prefer to use destructuring because, again, props it's just an object. It is just a JavaScript object. And so I can destructure it the way we would destructure any other JavaScript object. I like doing that because it allows me to see at the top of my function, what props does this component expect? It expects these, instead of having to dig through here and try to find every time I do props dot something or other. So I just prefer destructuring. And you can also destructure directly in line, which was the thing that I was doing earlier, where I did this. That's just another form of destructuring. Doesn't really change how anything works. And in to-do form, I do it more explicitly in this manner. So, does that make sense?
Yeah, that's great, man. Thank you. I owe you a chai tay.
Happy to help. All right, do we have any more questions? All right. Well, then thank you all so much for coming. I'm sorry for going a bit over, but I hope you have fun with today's afternoon project. Redux can be hard. There's a lot going on in a lot of different files, and it can be difficult to reconcile all of those things. but I personally really enjoy Redux. I think it gives you access to some very powerful patterns, especially as the size of your application grows, and it's something that you're going to see out there in a while. So I hope you have fun. It's a difficult project, but I believe that all of you are going to learn a lot from it, and I'll see you all later.